Water treatment often includes the use of toxic, reactive, or flammable materials as a part of our treatment strategy. Most of the time, these materials are used safely. However, when they're not properly stored or controlled, there is a potential of an accidental release. OSHA has a standard called Process Safety Management of Highly Hazardous Chemicals, specifically targeting this possibility.
The major objective of process safety management is to prevent the release of highly hazardous chemicals, especially into locations which could expose employees and others to serious hazards. An effective process safety management program requires a systematic approach to evaluating the entire water treatment process, focusing on the hazards associated with processes using highly hazardous chemicals. For example, TQ is the total quantity of chemical that can potentially be released during a spill or other abnormal process situation. The TQ for chlorine and hydrogen sulfide is 1,500 pounds. The TQ for ammonia is 10,000 pounds. The OSHA Standard for Process Safety Management, or PSM, has a number of key elements that are relevant for the water treatment industry. In this presentation, we will explain how OSHA's definition of process impacts water utilities, the process hazard analysis, how utilities ensure the mechanical integrity of equipment, as well as appropriate operating procedures and limits, the employee training aspect of PSM, and the response and review of incidents or releases. The ultimate goal is to develop and maintain written safety information identifying workplace chemical and process hazards, equipment used in the processes, and technology used in the processes. To accomplish this goal, utilities should perform a workplace hazard assessment, including identification of potential sources of accidental releases, identification of any previous release within the facility that had a potential for catastrophic consequences in the workplace, estimation of workplace effects of a range of releases, and estimation of the health and safety effects of such a range on employees. A Job Safety Analysis, or JSA, should be created for each process. Job safety analysis is essentially the assessment of work activities and the workplace to establish whether adequate precautions are in place. In other words, it is the systematic identification of potential hazards in the workplace as a step to controlling the possible risks involved. Water utilities should establish a system to respond to the workplace hazard assessment findings, which will address prevention, mitigation, and emergency responses. A memorandum of understanding should be developed with local emergency responders that outlines the planned and coordinated response to incidents. The OSHA PSM standard calls for the development and implementation of written operating procedures for the chemical processes, including procedures for each operating phase, operating limitations, and safety and health considerations. Another key element of the standard is written safety and operating information for employees and employee training, and to investigate and document every incident that results in or could have resulted in a major accident in the workplace, with any findings to be reviewed by operating personnel and modifications made if appropriate. Process safety management applies to those companies or utilities that deal with any of more than 130 specific toxic and reactive chemicals in listed quantities. It also includes flammable liquids and gases in quantities of 10,000 pounds or more.
To fully understand PSM and its many requirements, we need to discuss how OSHA defines the term process. Process means any activity involving a highly hazardous chemical, including storing, using, manufacturing, handling, or moving such chemicals at the site, or any combination of these activities.
As mentioned earlier, process safety management must include information on the specific hazards of the highly hazardous chemicals used or produced by the water treatment process. A key tool for this is the Material Safety Data Sheet, or MSDS. The MSDS contains information on the hazards of each highly hazardous chemical used in a water utility. Critical information included within the MSDS is toxicity, permissible exposure limits, physical data, reactivity data, corrosivity data, thermal and chemical stability data, and hazardous effects of inadvertent mixing of different materials. Utility employees also need information on the technology of the process. This includes a block diagram or simplified process flow diagram, the process chemistry, maximum intended inventory of chemicals, safe upper and lower limits for such items as temperatures, pressures, flows, or compositions, and an evaluation of the consequences of deviations, including those affecting the safety and health of employees. Next is information on the equipment used in the process. For example, materials of construction, piping and instrument diagrams, electrical classification, relief system design, ventilation system design, design codes and standards employed, and safety systems. Utilities must also document that equipment complies with recognized and accepted good engineering practices. These are specific process design and operational practices based on codes and standards of relevant industry leaders. In the case of water treatment operations, AWWA, the Chlorine Institute, and the National Fire Protection Association are some examples.
The true cornerstone of PSM is process hazard analysis, a careful review of what could go wrong and what safeguards must be implemented to prevent releases of hazardous chemicals.
The process hazard analysis is a thorough, orderly, systematic approach for identifying, evaluating, and controlling the hazards of processes involving highly hazardous chemicals. The process hazard analysis is best performed by a team with expertise in engineering and process operations. The team should include at least one employee who has experience with and knowledge of the process being evaluated. The team should also include a member of the utility's safety department or committee. A safety director provides valuable input and validates the PSM. The utility is expected to establish a system to promptly address the team's findings and recommendations. The utility is also expected to ensure the recommendations are resolved in a timely manner and the resolutions are documented. This documentation should detail what actions are to be taken and a schedule of the actions. All process hazard analysis must be updated and revalidated at least every 5 years and be kept on file to be made available to OSHA.
Another key component of process safety management is to develop and implement written operating procedures that are consistent with the process safety information. This provides clear instructions for employees conducting activities involved in each covered process.
Operating procedures should include steps for initial startup, normal operations, and temporary operations. Emergency shutdown procedures should be included with assignments for each operator in terms of shutdown responsibilities. Emergency operations and startup following an emergency shutdown should also be included. Operating limits must be established with consequences of deviation and steps required to correct or avoid deviation. Employees need to be aware of all safety and health considerations of each operation, such as the properties and hazards presented by chemicals used in the process, and precautions necessary to prevent exposure, including engineering and administrative controls and appropriate personal protective equipment. Utility workers need to understand what control measures are taken if physical contact or airborne exposure occurs, and they should have a full understanding of utility safety systems, including detection and suppression systems. It's also important that utility workers always consider safe work practices such as lockout-tagout and confined space entry.
As with so much of what we do here at the water plant, the key to implementing these procedures is with an effective training program. making sure the information and policies that we have established and are discussing here find their way into our daily routines.
PSM requires that each employee presently involved in operating a process or a newly assigned process must be trained in an overview of the process and its operating procedures. Refresher training is to be provided at least every 3 years, or more often if necessary, to ensure that the employee understands and adheres to the current operating procedures of the process. A record must be kept containing the identity of the employee, the date of training, and how the employer verified that the employee understood the training. Again, available for OSHA review.
Water utility employees and the management team, as we've noted, are certainly key components of process safety management. But we also need to consider our hardware. More precisely, the mechanical integrity of critical process equipment to ensure it is designed and installed correctly and operates properly.
PSM mechanical integrity requirements apply to the following equipment: pressure vessels and storage tanks, piping systems including piping components such as valves, relief and vent systems and devices, emergency shutdown systems, controls including monitoring devices and sensors, alarms and interlocks, and pumps. The first line of defense a utility has available is to operate and maintain the process as designed and to keep the chemicals contained. This is backed up by the next line of defense, which is controlled release of chemicals through venting to scrubbers or flares or to surge or overflow tanks which are designed to receive such chemicals. Other lines of defense would include fixed fire protection systems like sprinklers, water spray, or deluge systems, monitor guns, design drainage systems, and other systems which would control or mitigate hazardous chemicals once an unwanted release occurs. Inspection and testing must be performed on process equipment using procedures that follow recognized and generally accepted good engineering practices. Each inspection and test on process equipment must be documented, identifying the date of the inspection or test, the name of the person who performed the inspection or test, the serial number or other identifier of the equipment on which the inspection or test was performed, a description of the inspection or test, and the results of the inspection or test. Equipment deficiencies outside the acceptable limits defined by the process safety information must be corrected before further use.
As we mentioned at the beginning of this program, in the vast majority of cases, water utilities operate safely as we utilize various hazardous chemicals. But what if there is some sort of incident or release, even a minor one?
A crucial part of the process safety management program is a thorough investigation and performance review of incidents to identify the chain of events and causes so that corrective measures can be developed and implemented. Accordingly, PSM requires the immediate investigation of each incident that resulted in or could reasonably have resulted in a catastrophic release of a highly hazardous chemical in the workplace. An incident investigation should be initiated as promptly as possible, but no later than 48 hours following the incident. A more thorough intensive review should take place later when an appropriate review committee is assembled and available. The investigation must be by a team consisting of at least one person knowledgeable in the process involved, including a contract employee if the incident involved the work of a contractor, and other persons with appropriate knowledge and experience to investigate and analyze the incident thoroughly. An investigation report includes at least date of the incident, date the investigation began, description of the incident, factors that contributed to the incident, and recommendations resulting from the investigation. A system is established to promptly address and resolve the incident report findings and recommendations. The utility is required to keep these incident investigation reports for 5 years.
If, despite our best planning and precautions, an incident occurs due to man-made or natural events, it's obviously critical that our emergency pre-planning and training will allow us the ability to execute appropriate response actions. actions that are spelled out in the utility's emergency response plan.
Each utility must address what actions employees are to take when there is an unwanted release of highly hazardous chemicals. An emergency action plan for the entire plant must be developed and implemented in accordance with the provisions of OSHA rules. A comprehensive emergency plan is an essential tool that is used before, during, and after a disaster to meet the objectives of a utility's critical mission. An emergency plan assesses the vulnerability of the water system to potential threats, identifies mitigation measures to reduce or eliminate vulnerabilities and protect system assets, provides complete incident response and crisis communication procedures, and includes a description of a post-event recovery process. Drills, training exercises, or simulations with the local community emergency response planners and responder organizations is one means to obtain better preparedness. And finally, to be certain process safety management is effective, employers must certify that they have evaluated compliance with the provisions of PSM at least every 3 years. The compliance audit must be conducted by at least one person knowledgeable in the process, and a report of the findings of the audit must be developed and documented, noting deficiencies that have been corrected. The 2 most recent compliance audit reports must be kept on file. As mentioned at the beginning of this presentation, PSM is an OSHA standard and is primarily concerned with on-site employees' safety. EPA standards and a risk management program also provide critical elements of water treatment chemical safety as they address off-site and public concerns. It is important to take a multifaceted approach and to be compliant with all relevant programs and agencies.
Process safety management is everything from the proper storage and use of chemicals to the appropriate emergency response if there is a leak. It's a comprehensive approach focused across the utility, the responsibility that is shared by all of us, management and employees.